So we're in week 11 already. That means our final exam will be in a couple of weeks. Make sure you check the final exam schedule posted on the student portal and have that date in your calendar. And remember that even though we don't have tests on these final weeks of classes, these will be represented heavily on your final exam. So we need to look at the graphs of sine and cosine. We just don't have time this semester to also look at the graph of tangent since it is a little bit different than these two graphs. So let's start by filling in the intercepts on this unit circle here. So you'll notice that I also filled in the angle measures, but I used radians because that's what we're going to use when we're graphing. You could use degrees, but I think more commonly you're going to see it in radians, so let's practice that way. Now I have two tables here where I want you to fill in the values for y. I've given you x. Let's first of all fill in for the equation y equals the sine of x. So in the first place here, I'm looking for y when I'm asking for the value of sine of 0. Of course, that means we're at 0 radians, and we know that because we were looking at points on the unit circle, sine is simply equal to 0 or 0 over 1. When x is pi by 2, we're looking at the sine of pi by 2. We see that sine is equal to 1. Or hopefully you've memorized these values. Fill in the rest of this table. So when we're given the equation y equals sine of x, these are our values for y. Now I know this can be a little bit confusing because we talk about sine as the ratio of y over r, but that y refers to our point on the unit circle or our side on a triangle. The y here is the answer to our equation. So try not to be confused with those. It takes a little bit of practice. Fill in the second table using the equation y equals the cosine of x. So you should have these answers here. Now we're going to use these points in order to graph our sine function and our cosine function. So we're going to start here by graphing y equals the sine of x. Let's do this by following a couple of steps that I hope you're always going to use when you're graphing the sine and cosine function. We'll first label our y-axis and our x-axis. And if you notice, if you go back to that chart, you should have that paper in front of you, you see that the highest value on the y-axis is 1, and the lowest value on the y-axis is -1. The second thing we're going to do is divide our x-axis on both sides of the y-axis into 4 intervals. And you see that our first value after 0 was pi by 2, and then pi, 3 pi by 2, 2 pi. The same thing in a negative direction. Now I'm going to suggest that the most important point for our graph y equals sine of x is the y-intercept. Can you find the y-intercept? Our y-intercept, of course, is found by letting x equal 0. So we have our y-intercept here. I'm going to strongly suggest that you memorize this point. Now, if you notice the x-intercepts, you're going to see that they are every second interval on the x-axis. At pi 0, 2 pi 0, negative pi 0, and negative 2 pi 0. Putting on your x-intercepts should always be the next step. And then we find that at pi by 2, we have 1, 3 pi by 2, negative 1. And our graph is above the x-axis 0, below the x-axis 0, and in fact it keeps going. So you need to have an arrow there. I would probably deduct marks on your test or exam if you don't put that there. In the other direction, we see that at negative pi by 2, y is equal to -1, and at 3 pi by 2, +1. So notice that our graph is always above the x-axis, below the x-axis, above and below. In fact, we call this a sinusoidal wave. This wave is seen with all kinds of applications, electrical currents, sound waves, sometimes weather. I was thinking about water. Sinusoidal wave, there we go. Now looking at this graph, y equals the sine of x, you should be able to fill in the domain and range. If you have those notes in front of you, you should have also filled in the y-intercept. I used my red pen. I hope you did as well, or maybe you have a purple one or green one or a highlighter, but you need to have that y-intercept memorized. That's always going to be our starting point for y equals the sine of x. What about symmetry? What kind of symmetry does this have? Well, we already talked about symmetry when we looked at the properties using our expressions. We said that sine is an odd function. I hope you can see that if you hold your pencil on the origin and rotate this graph 180 degrees, it's going to look exactly the same. We also know that given opposite values of x, for example, pi by 2 and negative pi by 2, the values of y are the opposite, 1 and -1. Why don't you write down the x-intercepts, just the ones that you see here, because of course there are an infinite number. Now, as I said, we can't list all of the x-intercepts. There are an infinite number of x-intercepts. We can see that this graph, oops, where'd it go, continues infinitely to the left and infinitely to the right. So how do we make a list of all of the x-intercepts without showing them all? Well, we're going to use our set notation. And when we look at our list here, we see that we're multiplying pi by +1, by +2, by 0, by -1, by -2. We're multiplying pi by integers. So we can say that our set of x-intercepts is the set of all numbers x such that, sorry, my brace bracket doesn't look very good there, x equals k times pi, where k is any integer. We're multiplying by integers, -2, -1, 0, 1, 2. We're not multiplying by fractions. Now remember, we also said that sine is a periodic function. We said that sine repeats every 360 degrees or every 2 pi radians. So the period is 2 pi. But let's go back and look at the graph and see what that means. If we start here at 0 and go to 2 pi, we can see that we have one complete wave. It starts at 0, goes above, 0, below, and back to where it started. That is one period length on this wave. We could choose to start anywhere. We wouldn't have to start at 0. If we went from -pi to +pi, that's also a period length of 2 pi radians. And you see here, we're starting at 0, going below to 0, above to 0. One complete section of the wave. So it doesn't matter where you start when you're trying to find the period length. It's just easiest if we start at 0 and go to 2 pi here. We can see that period completing itself, one full wave. Above the axis, 0, below the axis, and back to 0 again. When we look at graphing transformations, the same transformations that we used back in week 3, we used with exponential function graphs, we used with log function graphs. We will be using those same transformations here. We will also be talking about the amplitude. And the amplitude is the highest point on the graph minus the lowest point divided by 2. So we said that the highest point on this graph was 1. The lowest point was -1. Divide by 2. We see that the amplitude, 2 over 2, is equal to 1. Of course, if we change our equation, the amplitude can change. Actually, if we change our equation, the period length can also change, as can the intercepts. So that means we should memorize some key points for this graph, some of the basic x, y values. I suggested that the y-intercept is the one point you want to have memorized. And then if we go back to our graph, I would say if we just memorize the points in a positive direction, we have key points that will help us figure out the rest of this graph. Why don't you take a moment and write those down? It should be pretty easy to memorize these key points. First of all, if I look at my x values, they're going up by 90 degrees or up by pi by 2 radians. 0, 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. And then my y values just go between 0, 1, and -1. In the next lecture, we'll look at our cosine function graph. Oh, one more thing I wanted to mention here that I didn't have written down, and that was the absolute maximum and the absolute minimum. Maximum would be your highest point, so we can see that the absolute maximum on this graph is equal to 1. The absolute minimum, our lowest point, is equal to -1.